Hello friends, in this particular video we will talk about basic arithmetic and mathematical functions. The simplest uses of R is performing basic arithmetic operations. R uses notations for mathematical operations such as plus, minus, multiplication, division and so on. We use parentheses to group the operations. We write mathematical expressions into the R console or R studio and press the enter key to execute. R evaluates the expressions and displays the results. Now we will talk about various interactive R operations, R arithmetic operations and mathematical functions. For basic arithmetic operations, first of all, we talk about the addition. Now for addition, we may use like this way. So 3 plus 2, 3 plus 3 is equal to 6. 13 plus 23 is equal to 36. Similarly, 10 minus 8 is equal to 2. 10 minus 18 is equal to minus 8. Okay. For multiplication, we may use 7 into 8 is equal to 56. 17 into 8 is equal to 306. Now for division, 17 divided by 18 is equal to 0.94. Clear? 10 divided by 8 is equal to 1.25. 10 divided by 5 is equal to 2. Okay. Now we can write the mathematical expression also. Suppose 10 minus 9 into 7. The answer is minus 53. And we may use the parenthesis also to group the operation. So 10 minus 9 into 7, it is 7. Okay, so in this particular expression, 10 minus 9 into 7, we do not use the parenthesis, and the next in this particular part we use the parenthesis. So we may use parenthesis or we may not use parenthesis. Okay. Now I am giving you one more example. Say 2 plus 8. So this is for what? This is for addition. Okay. Now this hash function is a comment character. Okay, so 2 plus 8 is equal to 10. So kindly note that hash is the comment character, that is all the text in the line following is this hash is treated as a comment, and after hash R doesn't execute. Okay. Now we discuss about some basic mathematical functions. Now R language support various mathematical functions to implement, for example, square root, exponential, logarithmic, modulo, etc. Now for square root, we use sqrt. So square root of 10 is equal to 3.16. Square root of 3 is 1.73. Okay. Similarly, square root of 8 is equal to 2.82. Square root of 9 is 3. Okay. Now for exponents, so we can implement e to the power x also. So e to the e square, what is the value of e square? What is the value of e to the power 8? So what is the value of e? The value of e is 2.7182. So exp1, it returns the value of e, 2.718282. Now if you want to execute e square, so the value is 7.3890. E to the power, say 10. Okay. Now similarly we can write e to the power minus 8, e to the power minus 4. Okay. Next, to implement the log functions, suppose we write log 10. So log 10 means the answer is 2.30258. So log 10 is nothing but log 10 base e. Suppose log 2. base e. Okay. Now explicitly we can define the base also. So log 2 base 10 means log 2 base 10 is 0.30103. Log 2 base 2 is 1. Okay. Log 10 base 2 is 3.321928. We can omit this particular base word also. So log 10 comma 2 means log 10 base 2. Log 10 comma 10 means log 10 base 10. Okay. Or we can write this way, log 10 means log 10 base 10, log 20 base 10, log 200 base 10, like this way. Okay. Next, for integer division, so to know the integer part of a division, we use like this way, 10 modulo division modulo 2. So it will return the quotient part. Suppose 13 modulo division modulo 2, the quotient is 6. Similarly, 145 modulo division modulo 3, the quotient is 47. Now for modulo function, suppose if we omit the modulo, 143 modulo 3, it will return the remainder. So 143 modulo 3, it is remainder is 2. 143 modulo 10, the remainder is 3, so on. Kindly note that modulo is very useful for testing whether the number is odd or even. Suppose 143 modulo 10, the answer is 1. So 143 is the odd number. Similarly, if it is 140 modulo 2, here it is the answer, the remainder is 0. So that means 140 is even number. So already you know, if the modulo the remainder is 0, that means it's a even number, and if the remainder is 1, that means it's an odd number. Likewise, to test if one number is an exact multiplication of some other number, suppose whether 15421 is a multiple of 7 or not. That is 15421 is multiple of 7 or not. So if it will return true, that means 15421 is a multiple of 7. But if it will return say false, that means 15321 is not multiple of 7. Clear? Next we will talk about the assignment operator. So we can use any one of that. Suppose x equal to 9, that means x is 9. Similarly, we can use x arrow 9, 8 or 9. So the effect is same. So same x equal to 9. So in this particular class, we use this particular notation. We use the arrow notation for assignment operator. Okay. Now, rounding function. Suppose you write round 18.768976.2, so it will return 18.77, so 2 decimal point. Suppose if you write, so if you write say 6 or say 3, so it will work like this way. Now R supports the trigonometric function also. The trigonometric functions are measure angles in radians. A circle is 2 pi radians, that is 360 degree. So a right angle is 90 degree, that is pi by 2 radians. We use pi to denote pi. Suppose pi, the pi value is 3.141593. Clear? Now, so sine pi by 2, it is 1. Clear? Cos pi by 4, it is 0.70. Okay. Similarly, Sine pi by 4, it is the same value. Next, tan, it is 1. Similarly, for inverse trigonometric transformation or for inverse hyperbolic trigonometric function, we use as follows. So, a cos h x, a sin x, a tan x we use for inverse trigonometric transformation, a cos h x, a sin h x or a tan x we use for inverse hyperbolic trigonometric functions. For example, a cos pi by 4, clear, or a cos h pi by 2. So, a cos is for inverse trigonometric function and a cos h is for inverse hyperbolic trigonometric function. Now, for the absolute value of x, that is ignore the minus sign, we use the ABS function. So, ABS minus 9.8, it is simply 9.8, ABS 10.8998, it is 10.8998, so it will ignore the sign. Now, for factorial, say 6 factorial, what is the value of 6 factorial, or factorial of 3, factorial of 8, so use the factorial function. So, factorial of 3 is equal to 6, factorial of 4 is 24, factorial of 5 is 120, factorial of 10 is this one. Okay. Now, for the binomial coefficient means 3 factorial divided by x factorial into n minus x factorial, that is ncx. Okay, so how to implement this particular part? So, here we choose 10, 2, that means 10C2, the answer is 45, 10C4, it is 210, 10C7 is equal to 120, and so on. Now, floor and ceiling function. Now, for greater integer less than x, we use the floor function. So, floor 1.89, it is 1, floor 8.89, it is 8, floor 8.9 is equal to 8, floor 8.2 is equal to 8. Now, for the smallest integer which is just greater than x, we use the ceiling function. So, we write ceiling 1.8 is equal to 2, ceiling 4.8 is equal to 5, ceiling 4.1 is equal to 5, and so on. Now, there is another function that is called trunc, TRUNC. Now, for the closest integer to x, between x and 0, we use the trunc function TRUNCx. Now, see this particular trunc. So, trunc 1.5, the answer is 1, trunc 1 minus 1.5, it is minus 1. So, actually it extracts the integer part. So, if your value is positive, it is similar to the floor function. If the value is negative, it is similar to the ceiling function. Similarly, you can check another value also, say 9.15, the answer is 9, minus 119.9 is minus 190. So, it will extract the integer part. Okay. Now, number with exponent. For very big numbers or very small numbers, R uses the following scheme. So, for the big number, it is denoted like 1.2 e to the power 4 means this number, and 0.5 is equal to 5 means this one, or 19.2 e5 means this particular number. So, for big number, it is like xe some values. Similarly, you can write minus also. So, if it is minus, so 19.2 e minus 5 means 0.000192. Okay. Now, for the complex number, for example, 1.2 plus 8.9i. So, for the complex number, we use this particular function. So, 1.2 is the real part and 8.9 is the imaginary part, where I is the square root of minus 1. Okay. Now finally, to exit from the R or to quit from our session, we type Q brackets, opening and closing brackets, and enter. So it will ask whether we want to save it or not. So Y, press Y. Okay. So type Y to save the workspace, or type N not to save the workspace. Clear? Okay. So this is the end of this particular session. Thank you very much. Thank you very much.